Good morning, my dear students of first secondary. I am Mr. George Milad, and I am going to teach you math for this year. Today, we are going to complete our first lesson in algebra, solving quadratic equation in one variable graphically. Okay, let's go. Solving quadratic equation in one variable graphically. To solve the quadratic equation graphically, we follow the following steps. First, put the equation on the form of ax power 2 plus bx plus c. Let f of x equals ax power 2 plus bx plus c. Graph the function. Determine the points of intersection of the curve with x-axis. Then, the x-coordinate of these intersection points are the solution of the equation f of x equal 0. So, to find the solution of any quadratic equation graphically, first you have to graph the function. Then you will find the points of intersection of this graph with the x-axis. This point of intersection is the solution set of the equation. Of course, the first coordinate, which is x, is the solution set of the graph, as we will see in the examples. Okay? According to that, we have three cases. According to that, we have three cases. Okay? The first case, the curve intersects x-axis at 2 points. Here, in this example, you can see that the curve of the function intersects x-axis at 2 points. The curve intersects x-axis at the 2 points. M and 0 and L and 0. So, the solution set will be x coordinates only, M and L. The set whose elements are L and M. Okay? The second case, the curve touches x-axis at 1 point. Here you can see that the curve intersects x-axis at the point L0. So the solution set will be the x coordinate, which is L only. Okay? So the solution set is L. We know that the quadratic equation has at most two solutions. In the first case, you have the two solutions, which are L and M. In the second case, you have only one solution, which is the point L0, and the solution set will be L only. Okay? In the third case, the curve doesn't intersect x-axis. Here you can see that the curve doesn't intersect x-axis. So the solution set will be phi, and this is in R. This is in the set of real number. In the set of real numbers. Okay? Here again, the curve doesn't intersect x-axis at any point. So the solution set will be equals to phi, and there is no solution for this equation. Okay. Let's start our examples. The following examples show the previous cases. Example: find graphically in R the solution set of the equation x power of 2 minus 2x minus 3 equals 0 using the interval from negative 2 to 4. Closed negative 2 to closed 4. Okay. Here you are going to use the calculator to form the table. Mode 7 and you will choose table, and here by using the interval start -2 end 4, and step 1 you can see that the table will be x equals from -2 to 4, -2, -1, 0, 1, 2, 3, 4. Okay, and y will be equals 5, 0, -3, -4, -3, 0, and 5. Okay, here you can see that if you substitute x by -2, it will be -2 power 2, 4, -2 multiplied by -2 equals 4. So we have 4 plus 4 equals 8. 8 minus 3 will be equals to 5. Okay, and so on. If you substitute by -1, -1 power of 2 equals 1. -2 multiplied by -1 equals 2. 2 plus 2 equals 4. Here 1 plus 2 equals 3. 3 minus 3 will be equals to 0. Okay, if we start to graph the function, you will find that -2 and 5. -2, you will go to -2 on the left hand side, then 5 up, so it will be this point, and -1 or 0. -1 or 0 lies in the y-axis, -1 on the x-axis, -1 will be on the left, and 0 on the x-axis. So the point will be -1 and 0. 0 and -3. 0 on the x-axis, so here is 0, and we will go down to -3. Okay, -3 between -2 and -4. So this point. Okay, 1 and -4. 1 here on the right of x-axis will go 1 step to the right and go down 4 steps, 1 and -4, 2 and -3, 2 on the x-axis and -3 down y-axis, down on the y-axis, 3 and 0 will be 3 and 0, 4 and 5, 4 to the right and 5 up, it will be this point. Then you are going to draw this curve by your hand, don't use any rulers, okay, don't use the ruler. So you will draw the curve of the function, as you can see. Here you will find that the points of intersection of the curve with x-axis is the 2 points, -1 and 0 and 3 and 0. So the solution set will be 3 and -1. Again, another example. Find graphically in R the solution set of the equation -x power 2 minus 4x minus 4 equals 0 using the interval from -5 to 1. By using your calculator, mode 7, start -5, end 1, step 1. You will form the following table: x from -5 to 1, -5, -4, -3, -2, -1, 0, 1. And y will be equals to -9, -4, -1, 0, -1, -4, and -9. -5 and -9, -5 to the left here and goes down to -9. So the point will be -5 and -9. -4 and -4, -4 to the left and go down -4. So the point will be -4 and 4. -3 and -1, -3 and -1. So the point will be -3 and -1. -2 and 0, -2 and 0. -1, -1, -1 to the left and -1 down. The point will be -1 and -1. 0 and -4, 0 and -4. 1 and -9, 1 to the right and 9 down, -9 down. Okay, And now you are going to draw the curve of the function. Okay, here the curve touches x-axis on the point, in the point -2 and 0. So the solution set will be -2. And the last example, find graphically in R the solution set of the equation x power 2 plus 2 equal 0 using the interval -3 and 3. Okay, solution. First, let f of x equals x power 2 plus 2. Let f of x equals x power 2 plus 2. And by using the calculator again, mod 7, write f of x equals x power 2 plus 2. Start -3, end 3, and step 1. Write the table. X equals -3, -2, -1, 0, 1, 2, and 3. Y equals 11, 6, 3, 2, 3, 6, and 11. Okay? Let's draw the curve of the function, -3 and 11, -3 to the left, 11 up, so we will find this point. -2 and 6, 2 to the left and 6 up, plot the point -2 and 6. Okay, -1 and 3, -1 to the left, 3 up, plot the point -1 and 3. 0, 2, very important note, 0, 2 lies on the y-axis, 0 and 2. 0 and 2 lies on the y-axis. 1 or 3, 1 to the right, 3 up, 1 and 3. 2, 6, 2 to the right, 6 up, 2 and 6. Okay, and the last one will be 3 and 11. 3 to the right, 11 up. Okay, here you can see that the curve doesn't intersect x-axis at any point, so the solution set will be equals to 5. Okay, let's go to another example. An easy example for you. Okay, each of the following figures show the graphical representation of the second degree function f. Find in R the solution set of the equation f of x equals 0 in each figure. Here he wants you to find the solution set of the quadratic equation graphically. So in figure 1 you can see that the curve of the function intersect x-axis at the 2 points here and here. Okay, -1, this point is -1 and 0, and this point is 2 and 0. Okay, so you will write that solution set is a set whose elements are excellent, -1 and 2. Okay, this is the solution set of the first question. Okay, let's go to figure 2. In this figure, you can see that the curve of the quadratic function, intersect x-axis at the point 1 and 0. Intersects the x-axis only in one point, 1 and 0. So the solution set will be the set whose element is 1. Okay, the last example, figure 3. Here you can see the curve of the function doesn't intersect x-axis. Okay, very good, excellent. So since the curve doesn't intersect x-axis, so solution set equals 5. This is the end of our first lesson in algebra, and it was a revision on what we have studied in third prep about solving quadratic equation in one variable x by using factorization and general formula. And the last one, finding the solution set graphically, which is the point of intersection of the curve with the x-axis. Thank you so much. Until we meet again in the next time, goodbye and good luck.